We are looking at lesson 3.2, a snow job. This one covers writing, interpreting, and evaluating algebraic expressions. This is on page 297 of your book. Under the section where it starts the classwork, it says if you were running a business like one that sells snow cones, you'd probably have a lot of data related to your costs and the amount of money you can make. And if you had also completed the first 2 units of this course, you'd know a lot about organizing and working with data. So let's put some of the stuff we've learned to work by studying the operation of a snow cone stand. First, we'll need to know some terminology from business and economics. The amount of money that a business needs to spend for their operation is known as their costs. The amount of money that customers pay them for their goods or services is called the revenue. The difference between these two numbers is the amount of money that the company makes or loses, which is called profit. Number 1 says when a company is making money, which is the goal, the profit will be positive. What is the relationship between revenue and costs when this happens? So if you are making money, we can say that your revenue is going to be greater than your costs. In other words, you're bringing in more money than you're spending, which hopefully makes some sense. Turn the page to page 298. They give us a spreadsheet that shows us the costs associated with running a snow cone business, as well as the revenue and the profit. Number 2 asks us if 300 snow cones were made, how many ounces of syrup are needed? So you want to take your finger and trace. And my highlighter's not working, so we'll forget that. We won't use the highlighter for now. But go across from where it says 300 snow cones. Follow that across until you get to the ounces of syrup required. How many ounces of syrup are required for 300 snow cones? 600 ounces. Then they ask us a second question. They ask us, what about 500 snow cones? So look at the last row, follow it across until you get to the column titled syrup, and read that number. It tells us that there would be 1,000 ounces of syrup needed. Number 3 says that a formula was typed into cell D5 to obtain the result you used to answer question 6. That's not question 6. He has a lot of typos there. He answered question 2. What formula would give the correct result? So this is the formula that's going to be use cell A5. So when I had 300 snow cones, I needed 600 ounces of syrup. When I had 500 snow cones, I needed 1,000 ounces of syrup. I am taking 2 and multiplying by the number that's typed into cell A5. That will give me the formula for every amount of snow cones used. They ask us to write a verbal description of the relationship between the number of snow cones used and the number of ounces of syrup that will be needed. What we've just written by writing our formula is that the number of ounces of syrup needed is twice as big as the number of snow cones sold, or 2 ounces of syrup are needed for every snow cone. So we could say simply 2 ounces of syrup are needed for every snow cone. Number 5 asks us to complete the following sentence. If X represents the number of snow cones sold, then what expression represents the number of ounces of syrup used? We just said it's twice the amount, so to write that as an expression, we write 2x. Moving on to page 299, it says when writing an expression that represents some quantity, we will often turn that expression into an equation, or a formula if you like, by using a letter to represent the value of the expression. Using the letter S to represent the amount of syrup, let's write a formula. The amount of syrup is equal to 2 times X, where X is the number of snow cones sold. Number 7 says, does the number of snow cones sold depend on the amount of syrup used, or does the amount of syrup depend on the number of snow cones sold? The amount of syrup depends on the number of snow cones. Got crammed in there a little bit, sorry. Number 8 says, in your formula from question 6, which is the independent, or the input value, and which is the dependent. Since we said that the amount of syrup depends on the number of snow cones, syrup, the S, is dependent. And X, which is the input, is the independent. Is the relationship between the amount of syrup used and the number of snow cones sold linear, exponential, or neither? Because it's a constant, it's 2 ounces per every snow cone, we are going to say that's linear. It is constant. Two ounces per, can't write my E there, snow cone. Number 10 asks us, if X represents the number of snow cones sold, what quantity described in the spreadsheet is represented by 5X? So go back up and look at your spreadsheet. 5X, if I have 100 snow cones sold, what would 5 times 100 be? It would be 500. Run your finger across that row until you find the number 500. Read the title above that column. It appears that that is the amount of ice, the ounces of ice. Let's double check and make sure we're correct. If I had 200 snow cones sold, what would 5 times 200 be? It would be 1,000. Run your finger across the 200 row until you hit 1,000. That is indeed the ounces of ice required. Moving now to page 300. If 70 snow cones are sold, what is the value of 5 times X, or 5 times 70? It would be 350. What does that tell us? It tells us that we use 350 ounces of ice for how many snow cones? 70 snow cones. If you were to graph the data in columns A and J from the spreadsheet, so we're looking at the snow cones sold, and J is the total costs. Will the number of snow cones on the horizontal axis, with the number of snow cones on the horizontal axis and total cost on the vertical axis, would the graph be a line? Well, let's look at that column J back in our previous chart. We go from $245 to $557, so it went up by $12. 257 to 269. Looks like it goes up by $12 again. Looks like we're constantly going up by $12. So my answer would be yes. It will form a line because it increases at a constant rate. It increases at a constant rate. Let's go ahead and plot these points. So when I had 0 snow cones sold, my total cost was $245, which is just a little less than $250. When I sold 100 snow cones, my total cost was $257, which is just a little more than $250. Dots are hard to do with the stylus. When I sold 200 cones, my costs were $269. You'll notice it's a very flat line. Mine's probably less of a line than it should be. 300, the cost was $281. We're getting closer to that 300 mark, but we're not there. Whoops, I just put it in the wrong place. Let's see if my eraser works. Oh, it does. Grab my pen again. So at 300, we were at 281. At 400, we were at 293, so we're really, really close to 300, and then we're just over 300 for this. It's a very, very flat line. If I was more accurate, it would be a straighter line, but it does indeed form a line. What is the y-intercept of this line? Where does it cross the y-axis? Or better yet, when there are 0 snow cones sold, what is the startup cost? The startup cost is $245 when there are 0 snow cones sold. 14 asks us to write the unit rate that describes the combined costs of all supplies needed for snow cones sold. Well, we've just discovered that we were going up by $12 per 100 snow cones. So I go up by $12 per 100 snow cones. You can either use your calculator to divide that out, or you can divide by moving the decimal over 2 places. My unit rate ends up being 0.12 or 12 cents per snow cone. You're asked then to pick 2 points from the graph or the table, which is probably easier to find exact points, and find the slope of the line. So let's pick 2 points from, let's go from the table, it's a little bit easier. Let's use 0, 245, and let's go ahead and use 100. And the cost at 100 was $257. And let's go ahead and find the slope. We subtract the y values, so I take, let's do this in a different color to make it stand out a little bit. 257 minus 245. On the bottom, I have to pick the x that went with the 257, which is 100, minus 0. I get 12 over 100. Almost out of room here, which does give me that 0.012. Again, it confirms what we figured out in the previous problem. Turning to page 301. They tell us if each cup costs a penny, 1 cent, write an expression for the total cost in dollars of the cups based on X, the number of snow cones sold. So if I sell 1 snow cone, how much is it going to cost? It's going to cost 1 penny. If I sell 2 snow cones, it's going to cost 2 cents. 3 snow cones, 3 cents. What am I doing? I'm taking the cost of the cups and multiplying it by X, the number of snow cones. 17, they ask us to do the same thing, but they're saying now that 4 cents is spent on the syrup. Write an expression. Similar to question number 16, it's going to be 0.04x. 18 then says we spend 7 cents on ice, so 0.07 X. Now here comes my favorite part. It says add up all of those costs. So 0.01x plus 0.04x plus 0.07x ends up being 0.12x. Does that number look familiar? Hopefully it does. The last problem for classwork says the total cost of selling snow cones is the sum of the variable cost for supplies, which you just found, and the fixed cost. These are the costs that aren't affected by the number of snow cones sold, like rent, insurance, licensing, etc. Look back at the table to find the fixed cost for this business. Then use that equation to write an equation in the form C equals an expression. What are the fixed costs? Go back to your chart. How much did you have to pay your total costs, regardless of if you sold any snow cones? 0 snow cones sold, you still paid $245. So our cost is going to be that $245, that initial cost just to set up my business, plus how much per snow cone? We just found that above and in several places, 12 cents per snow cone. So that's the total cost of my business in making snow cones. You can now work on the group assignment for section 3.2.